again, just to review, three ways in which we write equations now. Solve quadratics are these three ways. And yesterday, our primary focus was on the factored form of this. We're going to focus still on that factored form today. Yesterday we talked about how we use the roots to graph the equation to solve the graph, all right, or find out all the information that we need from the graph. Today what we're going to do is we're just going to solve quadratic equations by factoring. So all you're doing today is you're brushing up on your factoring skills. Okay, and this again is one of those skills that's extremely valuable moving ahead into the grade 12 courses. Okay, so we want to make sure that we have a good understanding. So all that we do today still reverts back to this and the roots and the x-intercepts and the zeros of the function. It's just we're going to use algebra in order to solve it. Now you may, because you have graphing technology, use the graphing calculator after the fact to solve and make sure you have it right. Okay, so that's the advantage that you have for this applied course, is that you can use the graphing technology and check your solutions. All right, so here's an example of a question. It says solve the following question. So I have 0.125 x squared okay, so in the current form that it's in, all right, what we want to do is we are going to get it to equal 0. All right, now if you imagine 0 as being y, it would be just graphing this equation and finding out where the zeros are of the equation. So first thing I do is I take and get it equal to 0. Now this is a very standard step that you're going to do anytime you have a quadratic equation. When you do this in grade 12, you're going to do this all the time as well. Okay, it's the one thing that when you see quadratic equations that are unsolvable in the form that they're in, you get them equal to 0 and then you factor them. Our ultimate goal is to get it into what we call the zero product equation. The zero product equation says this: if I have A times B and it's equal to 0, what does that tell us about A or B? One of them has to be 0. So if I have two terms multiplied together in which there's variables and they equal 0, then one of them has to equal 0. So we're going to find out what value gives me a value of 0 for the term. Now, I don't often like to use a value in front. So the very first thing we do when it comes to factoring is look for the greatest common factor. Okay? So I look at these numbers and I try and figure out, is there a greatest common factor in this? Well, it's hard to tell because we have decimals. So what I'm going to do then is I'm going to divide everything by the A value, because it's easier to factor questions if A is equal to 1. All right? So I'm going to divide everything by 0.125. So that gives me x squared subtract 0.875 divided by 0.125 minus 7x, and then plus 12 is equal to 0. All right? Now, if you remember what factoring is, okay, and we have to refresh, is we want to find the values that go into 12 that when I multiply together gives me 12 and add to give me negative 7. So what two values gives me that? So the first thing I do, when I have no value in front, when I have a value of, there's a value there, it's 1. When I have a 1 in front of the x squared, all right, what are the factors of x squared?
X and X.
X and x. What are the factors of 12 that add to give me 7?
3 and 4.
So I need a negative 3 and a negative 4. That's right. Okay? So that means that if x minus 4 is equal to 0, 0 times this will give me 0. If x minus 3 equals 0, 0 times that gives me 0. So for what value of x will I get a value of 0 here? So I go x minus 4 equals 0, or x minus 3 is equal to 0, and I solve for it. So what do I do here to solve for x?
Plus 4.
Plus 4. Over here,
Plus 2.
there's my roots. So if I were to graph this equation right here as written, I would find out that x equals 4, x equals 3 are my roots of my equation. That's why we also call them the zeros of the equation. That's also the reason we call them y-intercepts, because that's when when y is equal to 0. What are your x-intercepts? So there's the standard question for factoring.
Why were they negative and now they're positive numbers? Because we added.
What am I going to put here that's going to subtract 4 to get 0? Or, how do I get x by itself? Add 4 to this side. Make sense?
Yeah.
Okay. All right, any questions so far? Another example. 9x squared plus 42x equals 49.
Negative.
Negative 49. Negative 49? Negative 49. Okay? So what's the first step that I do?
Equals 0.
Equals 0. Good. 9x squared, add 42x, add 49 equals 0. What's the second step that I do?
But the first thing is
Then
the factor
Yeah.
form.
Not yet.
Greatest common.
Greatest common factor. Is there a value that goes into 49, 42, and 9? Does 3 go into 49?
No, 6 is common.
So none of them. Okay. But here's a unique situation again. Okay? And that is this. All right? The long way to do it. Because you may not recognize this. But the long way to do it is this. Product, sum, factors. Product, 9 times 49. Okay? So 9 times 49 is
441.
That's right. Okay? The sum is 42. So what are the factors of 441 that add to give you 42? So that's how we have to do that question. Okay? But if I look at this question a little bit closer, I'm going to notice something. And that is this. 9x squared and 49 are both perfect squares. Right? So then, I have to believe that if I take the square root of this, and the square root of that, I'm going to end up with this. Okay? So, this will only work if the square root of that and the square root of that, okay, if these are perfect squares,
All of them?
both of them,
Or just K?
they both have to be perfect squares. And then when I take the square roots of them, and I multiply them by each other, and multiply them by 2, I'm going to end up with that. Okay? It's a unique circumstance that this happens. How many roots do I have in this question then? 0, 1, or 2?
1.
I have 1 root. Because these are the exact same, right? Therefore, I go 3x plus 7 is equal to 0. Right? How do I solve for x?
Divide by 3 and subtract 7.
How about we do it in the reverse order of that?
Subtract 7.
Very good. Subtract 7. Divide by 3. I have one root for this equation. So going back to this, 441. What were the two numbers, the two factors? Anybody think they can get it?
21.
What is it?
21 and 21.
Yes, it is. 21. Okay, for you. Okay? The other way I know this, if I multiply that by that, it gave me another perfect square. So that worked out as well. All right? So again, I would check this by graphing at this point right here. So I put y in here instead of 0, graph it, and then find the 0 in that case. Just to check to make sure I've got that right. Okay, so you need to be able to factor without the calculator. But you are more than welcome to use the calculator to find your solution. Okay, make sure it's correct.
Where did the 21 come from?
Factors of this, that I had to give you that. 21 times 21 is 441. 21 plus 21 is 42. Okay, so let me go back to this part here. Let me do it on a separate page here. So I've got this at this point. This is again a refresher for you. Okay? So I have 21 and 21 were my factors, so I put them in instead of 42. So I go 9x squared plus 21x plus 21x, add 49 equals 0. Then I put brackets, very good. Brackets here, brackets there. What am I looking for now? Greatest common factor. Right? So what goes into both 9x squared and 21x? 3x. So that leaves me 3x add 7. The same thing right here. Oops, sorry. Oh, you don't do that there. This one's different. 21x and 49, what goes into both of them? And then we finish it that way. Okay? So that's the longer way of doing it. If I have a value here in which I can't change it to a 1, this is the process that I need to go through to get that. Okay? So if it's a value that you can't take out a greatest common factor, then this is the work that I do for it. Alright? Okay, so that's all that's new today. Are there questions from 7374 that you were working on yesterday? Anybody have questions from 7.4 or 7.3?
Number 7.
Page?
No, it's 190.
192? Okay. So we want the equation for this.
Yeah, I don't know how to do that.
Know what I mean?
I don't know how to do that.
Why?
I find it very confusing.
You find it very confusing. Okay, well I showed you two methods yesterday in which to do it. Method number 1 was use this equation here, if you know what the vertex is. And method number 2 is to use this equation if you know what the roots are and not the vertex. Correct? Is that what we did yesterday? Yeah? Do you know the vertex on that graph?
Yeah.
What is it?
-2 and 0.
So then my equation is y equals a, x plus 2 squared plus 0. Correct?
Yeah.
Because isn't my vertex for this h and k?
Yeah.
So you're following me so far?
Yeah.
So what do I have to find then?
No, A.
I have to find a, right? So now how do I find a? What else do you know from the graph?
The y-intercept,
Okay, so let's use it. What's the y-intercept?
0, 6,
0 and what?
6.
So I put 6 here equals a, 0 plus 2 squared. Right? What's 2 squared? A is equal to 6 over 4, which is equal to 3 over 2. So what's my equation for this function? Y, or f of x, equals 3 over 2.
Okay.
We did this yesterday, did we not?
Yeah.
Okay. We're going to do it using this because it's a little bit trickier. Because is the vertex also one of the roots?
Yes.
It's also the only root, is it not? So then a x plus 2 times x plus 2. And now you go through and you do the same process you did over here. Substitute in 0 and 6, and you'd end up with the same answer. Right? So you have two methods in which you can solve for it depending on what you want to use. This is clean and easy if you know the vertex. This one's better if we don't know the vertex but we know the roots. Make sense?
Yeah.
Is that better?
Yeah, way better.
Okay, good. Anybody else have questions today? All right, so that was all yesterday. Solving these two methods.
So we have to know both of them? How to
Yes.
solve both?
Yes. Okay. All right then. You have today to work on 7.4 and 7.5.